Let's take a look at the first section of the toolkit. So similarity occurs when two shapes are the same. So two figures have the same shape, but they don't necessarily have to be the same size. So here are some examples. The little star and the big star, they are both the same star shape. It's just that one is a little smaller and one is a little bigger. Same shape, maybe different size, similar. The same is true for these triangles. These triangles, even though they're facing different ways, they're the same shape, just different sizes. Now, when you're checking polygons, so straight-sided figures, if two shapes are similar, here's what happens. Number one, the angles are congruent, meaning they're equal size. And we show that with little marks. So this single angle mark and this single angle mark means those two angles are the same size. Two arcs and two arcs, those angles are the same size. Three arcs and three arcs, those angles are the same size. The sides, however, are not going to be the same because, again, the shapes are different sizes most of the time. But what you will find is that they are proportional. Here's what I mean. Find your corresponding sides. So in the big triangle here, the shortest side is the 1.5. If we compare that to the shortest side, and by compare I mean divide, make a ratio out of them, you end up with a factor of 1.5. Do the same thing now with this middle length side. So the middle length side on the bottom is the 4.5. The middle length side on the top is the 3. And once again, you're going to find that same ratio of 1.5. This is what we mean by proportional. For the long side, the same thing. The longest side on the bottom figure compared to the longest side on the top figure is again going to give you that same ratio. If you get that same fraction each and every time you set up corresponding sides, the relationship is proportional, and that's a property of similar polygons.